Welcome everyone to this International CML Foundation's key discussion on CML Latin America, where for the third and final discussion of this year's series, we will go back to the CML laboratory and ask how to get the best out of it in 2026. I'm Arlene, I'll be your moderator today, and before I introduce our experts, I'll take a moment to let newcomers to the Foundation know something about our work. So we are a physician and researcher-based organization seeking to share CML expertise globally. We do this through CML education via our case discussion forum, conversation groups like this one, the Knowledge Center, and highlighting significant papers and conference summaries for those who are unable to attend in person. Over the past 15 years, the Foundation has been working via preceptorships, in-person meetings, country-specific and regional discussion groups like this one, trying to make sure that no matter where in the world you are, CML physicians and researchers have access to the best possible knowledge, opinions, and expertise. The other side of our work is harnessing the power of global research. Our ideal is working towards a cure for CML, but along the way, we're trying to improve treatment pathways and patient outcomes as much as possible. So we have the Genomics Alliance, the TFR Alliance, we did lots of work around CML and COVID, hepatitis B survey of practice, and we're currently driving a pediatric CML study that should culminate in treatment recommendations for low and middle income countries, and much more to come. So that's a brief overview of the International CML Foundation, who we are and what we do. Please reach out to me if you have any questions or would like to know more about our programs. So again, our topic for today, how to get the best out of the CML laboratory. So it's my great pleasure to introduce our international experts, Dr. Dennis Kim from Toronto in Canada and Professor Sue Branford from Adelaide in Australia. Dennis is Professor of Medicine and a giant in the CML field. He's backed by popular demand and is becoming a regular in the Latin American and other regional discussion groups. It's a real privilege to share the floor with you again. Welcome, Dennis. Professor Sue is preceded by her reputation and is another giant in the CML field. Again, backed by popular demand, Professor Branford is a great friend and frequent contributor to the Foundation's work, and it's always an honor to share the floor with you. Welcome, Sue. Our regional experts are Dr. Isabel Giere from Buenos Aires in Argentina and Dr. Gabriela Jaramillo-Cooperman from Quito in Ecuador. Dr. Isabel brings a wealth of experience from the laboratory with her, and I'm so pleased that she's going to share some of that with us today. Welcome, Isabel. And this is Dr. Gabriela's inaugural appearance in the regional discussion groups as a topic leader, but I'm sure it won't be her last. I met Gabby earlier this year during our Climb for a Cure Education Day, and she took time to lead groups through her laboratory twice, 2 days in a row. She has a huge breadth and depth of knowledge, and I can't wait to hear her talking about some of the opportunities and challenges she works around on a daily basis. So I will hand over to Isabel to get her slides up. There we go. And while she's doing that, I will let you know that Isabel will start with a single, very rich in learning opportunity case, during which we will break for discussion. And then after that, we will go to Gabby, who will have 2 cases, and then we'll have a discussion around some lab reports. Isabel, looks like you are ready to go. Over to you.
Yeah. Thank you a lot. Greetings to all. And greetings for also to all people who are now learning with us in this space. Thank you to the International CML Foundation. So, how to get the best of our lab? This is a case, 10 years of monitoring that allowed to learn a lot. We go. This is a 45-year-old female patient. We received her under a treatment-free remission protocol in FUNDALEU, the Argentine stop trial, with a history of chronic myeloid leukemia. At diagnosis, she was in chronic phase. In 2016 with low so-called risk, Phi positive, and with transcript P210, B2A2 positive only by qualitative PCR in a local lab. So she started TK therapy during 6 years. She went well. The molecular monitoring was by reverse transcription quantitative PCR reaction in the local lab, and the molecular response in each time point was evaluated by RT-qPCR with the complete blood cell count assay that revealed normal results, and deep molecular responses were reported by the local lab during that period. On November 2022, she stopped the TKI treatment and entered the protocol to assure continuous molecular monitoring. And during the first year of during the molecular monitoring she was in this trial, normal complete blood cell counts and deep molecular responses were detected with no transcripts. So here is a timeline. We see the diagnosis. She stopped, and we evaluated from this point till today. In every time she achieved deep molecular responses. So at month 16, the time points correspond to month 15, really, of the follow-up during the TKI suspension. The samples show an abnormal leukocyte thick layer, but the molecular response was 5.0 with undetectable transcripts by real-time quantitative PCR also. So here began the challenge in the lab. In this point of evaluation, we saw a high count of blood cells. The transcripts were undetectable, but we performed a FISH study, and we obtained 95% of cells with a pattern of BCR-ABL positive. So here are the characteristics of the sample. No fusion transcripts, and here we see one fusion signal in the FISH analysis. Well, with this result, patient started second generation TKI, nilotinib, and after a month, she achieved complete hematologic remission, and after 3 months, she achieved complete cytogenetic remission. Well, the patient resumed treatment with her local physician, and samples collected for monitoring were sent also to FUNDALEU after entering the immunotherapy. Monitoring was performed by FISH until the molecular method was designed and established for personalized clinical use. So at disease onset, it's a classical CML with Philadelphia, BCR-ABL positive, B2A2, or E13A2. Here's the point, the breakpoints, the graphic of the translocation and the rearrangement. And we remember that the qualitative PCR was performed, so PCR products were obtained, by shell electrophoresis, they could be seen, and by size comparison, they were reported as B2A2. Well, here is the method applied at the onset, and here we have the band, and well, in that lab, they conclude that this was their arrangement. So we look forward the kinetic graphic from the onset, and we see here, this is a theoretical point because at debut, at diagnosis, the real-time quantitative PCR wasn't performed. So this point, we assume it's 100% or close to this point. And the first evaluation by RT-qPCR was on month 6, and it was a deep molecular response. And here we see how the results went along the time. So the transcript expression kinetics graph shows a non-gradual decrease. It was an abrupt in the transcript levels. So some questions arose from this situation. To solve the case, and well, in that point, we think a lot of things, we thought about a lot of things, and now I would like to hear, what do you think till this point?
Thank you, Isabel. We might start with Sue.
Thanks, Isabel, for sharing this case. So it is very interesting to see that very abrupt decline. So as you mentioned, there was only a qualitative test performed at the time of diagnosis that it looked like on gel electrophoresis, it looked like it was an E13A2 compared to the control sample. So it was reasonable. But I think it has highlighted that how important perhaps it is that to follow that up with a quantitative PCR of that same diagnostic sample. Because once you establish that it is a P210, then I think perhaps the next standard would be to test that diagnosis sample using the quantitative method that you're going to be using subsequently. So I'm not sure if that is routine. In our lab, we will always use the quantitative method first. We don't use the qualitative method. We use a quantitative first. If we can't detect the P210, then we will do a qualitative to try to determine. So that would be my first question, perhaps to you, Isabel. In this situation, do you do the same? Do you do a qualitative first and not a quantitative to ensure that diagnostic sample will work in the quantitative assay?
In our lab, at diagnosis, we perform real-time quantitative PCR.
Okay.
And fish, also fish. When the clinical case is very typical of a CML case, we expect to have, our expectation is to have a positive result by real time. But sometimes the real-time PCR is undetectable, so no transcripts, P210, but the fish is positive. So in that situation, we are in a cryptic variant or a typical arrangement we have to investigate. in this case, we couldn't test the sample from the diagnosis because that sample was in a local lab. They didn't have the sample anymore. So it was a challenge to characterize and to speculate to solve the case.
Mm-hmm.
Dennis, what do you think?
Yeah, I think that Sue's point is also very relevant. I think that checking the RQPCR first, just to make sure that we can monitor the transcript using the RQPCR, and then the confirming with RT-PCR. That is going to be very relevant approach. And also another thing is that clinically, we usually repeat the bone marrow in the patient having at least achieved MMR, then we repeat the bone marrow at around 12 to 18 months. That is not to evaluate the Ph positive chromosome, but in order to evaluate the additional cytogenetic abnormalities in a Ph negative clone. We also have to confirm that. If we have done that in this case, maybe we might be able to capture that kind of remaining Ph positive chromosome in the bone marrow. I'm not sure whether it is going to be some other solution to make sure that we can avoid any missing that kind of cryptic transcript or atypical transcript case. That's another way that we can try. Yeah.
Gabby, do you have anything to add from your laboratory?
Yes, in our case, we perform a quantitative PCR, but we also have a qualitative test for 30 or more fusion genes that we use for these patients that doesn't have that result at the first time. And we don't have fish in either cytogenetics, so it's nice to have another testing in hand. But in our case, we perform first the quantitative PCR.
Thank you, Gabby. We might go back to Isabel.
Yes. So to solve the case, we get in contact with a partner lab. The director of the lab is Dr. Michele Bianchini. The lab is the CEO of the foundation named FOCA. And we work together, my team and his team, to resolve this situation. I work with Karolina Pawlowski, which is the referent clinician in CML in FUNDALEU. And we embarked on this challenge, discover M16. We amplify the typical fusion transcript, then we sequence the product. A multi-primer combinations targeting different regions of the fusion transcript. We didn't know which was the fusion gene, but we could amplify only one fragment with this pair of primers. And here's the HEL, it's an example. And the amplicon was sequenced by Sanger. The Sanger sequencing, sorry for the quality of the chromatogram, but we can see here the BCR Abelson, here an insertion, and then the ABL gene. So the rearrangement characterized by Sanger was E13 or B2, an insertion, and then the exon A3 of the ABL gene. So at the onset, we supposed the rearrangement was B2A2 or E13A2, like this. And at this point, we could determine that determined that the rearrangement was E13, an insertion of ABL, and it's an intron region, part of an intron, and the A3 exon. Here is the configuration. So, well, then we verified in the sample with these primers, and using the primers, we could confirm the presence of this atypical rearrangement with expected size for the intron and A3 exons of the ABL gene. So, according to the chromatogram, a set of primers, a custom primer set, was designed for a personalized monitoring. So we have to use these primers to amplify this segment. And after that, with this custom primer set, an RT-qPCR was performed with the TACMAN probe, but the method was, thought was delta CT, the quantitation, and well, then we conducted sensitivity assays to perform the limit detection and sensitivity tests. So if we know the applications of the RT-qPCR, we can perform quantitative, absolute quantitative assays, like the gold standard method, but now we perform relative quantification with the samples, characterizing the amplification curves. So the molecular monitoring after the starting TKI therapy again was based on the typical sequence with personalized primers designed to detect a clone by RT-qPCR delta CT. That is a special mode, it's a relative quantitation. And this expression by RT-qPCR, by the delta CT method, was subsequently applied for the molecular monitoring. And this method showed detectable and low expression of the gene, suggesting that the disease has been controlled since the introduction of the second GTKI nilotinib. So the possibilities we considered that arose from these results were emergence of a different Phi clone, one could be or not, we don't know, or has the initial atypical arrangement been here but undetected? So it was unnoticed because at onset only qualitative PCR was performed.
Wow, what a case. We might start this time with Dennis.
Yeah, I think that it's a very interesting case. I expect that maybe that clone having a E13 insertion A2, there was a minor clone in the beginning, but probably E13 A2, there was a major clone. And then after the imatinib has been started, after that, after the clearing of all the major clone, which was E13 A2, then maybe the minor clone E13 insertion A2 clone has emerged as and becoming a predominant clone. That might be my explanation about that kind of discrepant result of the diagnostic PCR test versus a follow-up test, or maybe it could be a real, the acquired acquisition of that kind of clone, but my expectation is that maybe that kind of clone has been already existed at the time of initial diagnosis. That is my interpretation. Thank you.
Sue, what's your interpretation?
Well, my interpretation is different. I suspect that this was the primary break. To have 2 breakpoints at diagnosis is very unusual. We've never seen this. We've monitored probably more than 500 patients at diagnosis and established the breakpoints. And then in those where they do relapse, we haven't seen a change in the BCR-ABL transcript, although of course this could occur. So my question would be, the original size of the E13A2 in the qualitative PCR, was that similar with the PCR fragment? Was that similar to the E13 insertion plus the ABL exon 3? Were they a similar size? Because on a gel, it's actually quite difficult to see subtle differences. So Isabel, you might have an idea of the size difference, or whether the size using those original primers would
Yes.
be similar.
We suppose that the size are very similar because counting the nucleotides from each fragment, we could infer that I show in the next slides that the insertion match exactly in the same long size with the A2.
Right.
And I agree with you. I think that this rearrangement is the same as the rearrangement of the onset.
And
The
I also
sizes are
think,
very similar because they compensate in the structure.
yeah.
I can see you in this in the next slides.
I was just going to say, and also the supporting evidence is the fact that by 6 months, using the quantitative PCR, never able to detect a BCR-ABL transcript at all. So that's potentially supporting evidence that it was there right from the start.
Yeah.
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 Gabby, do you have anything to add, or shall we move on to these next slides, which Isabel will expand on these?
Yes, I think we can move on for the time.
Okay. Thanks, Isabel.
So I keep on.
Yes, please.
Well, sorry. So, well, our conclusions of the case is most likely this atypical rearrangement, E13 insertion A3, was the same as the onset. She responded very well to the first generation TKI, imatinib, but relapsed 1 year after discontinuation. So she relapsed because of this discontinuation. Switching to the second TKI therapy, the patient achieved again complete hematologic remission and cytogenetic response. So the baseline qualitative assay detected the fragment corresponding to the expected B2A2 isoform, and this result was reported as B2A2. It was never verified at diagnosis whether this transcript could be reliable monitored using RT-qPCR. Assuming this atypical rearrangement was present at the disease onset, we can conclude that the qualitative PCR at diagnosis was correctly interpreted solely by comparing fragment sizes. But the method for monitoring RT-qPCR, quantitative PCR, was not performed at diagnosis, neither MA3, neither close to the onset. So this was, for us, the major oversight or critical error for the lab. So to ensure proper molecular follow-up via RT-qPCR, the gold standard method is crucial to verify that the fusion transcript detected at diagnosis is really monitorable. So in summary, in the labs, in CML labs, biological mismatch is a critical concern, considering that the biological mismatch is a discrepancy between different diagnostic tests. If the FISH assay is positive, it means that the BCR and the ABL genes are physically fused at the DNA level, okay? The RT-qPCR for quantitation of the transcript levels exclusively evaluate the P210, B2A2 or E13A2, and B3A2 isoforms. However, the quantitative method, considered nowadays the gold standard for monitoring, can shield false negatives results if the patient carries an atypical molecular arrangement. So, thanks to all for this space. We learn a lot each time. We keep on learning with our patients. And well, time applied with enthusiasm and constant effort for deep knowledge is a transversal to all generations. So thank you to all.
Thank you, Isabel. Before we come back to our experts, Marina in the chat has asked, at diagnosis, how did the qualitative assay work if the break is in A3? We might take that question in with us to the experts and start with Sue, perhaps.
Yeah, I would say that the primers were located in Abel exon 3, and that's how it was captured rather than in Abel exon 2. If the primers were in Abel exon 2, absolutely, this transcript wouldn't have amplified. So that may be the case. I don't know if Isabel has any further information on where the primers were located.
Not at now. I have no idea how. I suppose they perform the biomed assay of that time. And well, in the biomed protocol, the set of primers that detect the B2A2 are from the B2 and A3, and they catch the size of 361 base pair for the B2A2. That's all.
Thank you, Isabel. Dennis, what are your closing thoughts and comments on Isabel's incredibly rich case?
I think that still I do not have the answer why this patient initially responded to the treatment of imatinib. And I assume that if the patient didn't achieve hematologic response, then they would do some other further investigation. But it looked like the patient already achieved a complete hematologic response. That's why they just continue to monitor the PCR testing. And certainly with the same E13 insertion A3, A2, with the same transcript type, but then patient eventually lost the response. I wondered whether there's some new appearance of ABL1 kinase domain mutation in this population. Maybe I wondered whether they have done that kind of testing. If it is not the case, maybe still I think that maybe initial mixture of different type of maybe a transcript type and their different sensitivity, they may explain why this patient initially responded but later lost the response. Maybe the different clone may have a different sensitivity to the treatment. And another good explanation is that after switching over to second generation, this patient start to respond again. So I wondered whether the ABL1 kinase domain mutation testing has been done at the time of loss of molecular response, hematologic response. Very complicated case, yeah. But I also learned a lot.
I want to add some details. When we saw the relapse in a tube, because we only have the tube with a sample, we could realize that after the time that the patient, we assume that the patient lost the response because she suspended the TKI. It's one possibility. And redirectioning to the second TKI, she recovered the response. Perhaps it would be interesting to perform the mutation analysis. I don't remember if we performed them. But well, with the second TKI, she achieved, after 1 month, the complete hematologic remission. And the cytogenetic complete remission after 3 months.
Mm-hmm. Great to hear that the patient was successfully rescued. That's great. Yeah. And I think that this case, as Katia already mentioned in the chat box, I think that this is very, this case illustrates how important it is to have a clear characterization of their transcript type at the time of initial diagnosis. I fully agree with that. Thank you.
Absolutely. Thank you so much, Isabel. We could talk about that for hours, but sadly we will move on. Thank you very much, Isabel, for a great case. That was a real head scratcher and fascinating. Thank you.